So u equals to log of x cube plus y cube plus z cube minus 3xyz. You need to show that dou by dou x plus dou y plus dou by dou z whole square into u equals to minus 9 by x plus y plus z whole square. Okay. Now let us understand LHS part. So it is dou by dou x plus dou by dou y plus dou by dou z whole square into u. This is same as dou by dou x plus dou by dou y plus dou by dou z into dou by dou x plus dou by dou y plus dou by dou z into u. So whole square, this is whole square, it is same as a into a. Now let us take u inside. It will be dou by dou x plus dou by dou y plus dou by dou z into, it is dou u by dou x, dou u by dou y, dou u by dou z. So first you need to evaluate dou u by dou x and dou u by dou y, dou u by dou z, add all the three and use the function to simplify the LHS part. Okay, now let us start with dou u by dou x. So u is given as log of x cube plus y cube plus z cube minus 3xyz. Now dou u by dou x is equals to, it is of the form log x, its derivative is 1 by x. It is 1 by x cube plus y cube plus z cube minus 3xyz. Now internal derivative, it will be 3x square minus 3yz. Okay, so you can see that this function is a symmetric function. That is, if you replace x by y and y by z and z by x, you are getting the same old function, hence it is symmetric function. So by seeing dou u by dou x, you can write the values of dou u by dou y and dou u by dou z. So dou u by dou y can be obtained by replacing x equal to y, y equals to z and z equals to x in dou u by dou x. So it will be 3y square minus 3 into zx by y cube plus z cube plus x cube minus 3yzx. So by seeing dou u by dou y, you can write dou u by dou z. Just replace y equals to z and z equals to x and x equals to y in dou u by dou y. It will be 3z square minus 3xy by z cube plus x cube plus y cube minus 3zxy. Now let us add all the three terms. Dou u by dou x plus dou u by dou y plus dou u by dou z. All are having same denominator. Okay. Now it will be 3 into x square plus y square plus z square minus xy minus yz minus zx by x cube plus y cube plus z cube minus 3xyz. Okay. So in lower standards you have the formula a cube plus b cube plus c cube minus 3abc is equals to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Okay. So according to the formula, it will be 3 by x plus y plus z. Okay. The formula is a cube plus b cube plus c cube minus 3abc is same as a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Okay. So by using this formula, this term is simplified into 3 by x plus y plus z. So we have obtained dou u by dou x plus dou u by dou y plus dou u by dou z is 3 by x plus y plus z. Okay. Now let us use the term to simplify LHS part. It is 3 by x plus y plus z. Now take the term inside. It is dou by dou x of 3 by x plus y plus z plus dou by dou y of 3 by x plus y plus z plus dou by dou z of 3 by x plus y plus z. Now it is of the form 1 by x, and 1 by x derivative is minus 1 by x square. You need to take internal derivative also. Minus 3 by x plus y plus z whole square, and internal derivative of x plus y plus z with respect to x is 1 plus 0 plus 0. And the next one, derivative of this term with respect to y, minus 3 by x plus y plus z whole square, and internal derivative of this term with respect to y is 0 plus 1 plus 0. And the last term, it is minus 3 by x plus y plus z whole square. It is minus 9 by x plus y plus z whole square, and it is the required right hand side. Now let us see the topic tangent plane in the chapter multivariable calculus. Okay. Now let us assume this part as a surface. Now let us assume at this point, let us identify the tangents. At this point, let us identify the tangents. So there can be any number of tangents. This is one tangent, this is one tangent, this is one tangent, this is one tangent. There can be any number of tangents for this curve at the point. Okay. The collection of all those tangent lines is called a tangent plane. Okay. Suppose this is some surface, and assume at some point these are all tangent lines. Okay. So we assume the figure as 3D figure. Assume that at this point these are all tangent lines. The collection of all these tangent lines is called tangent plane. Okay. So tangent plane is collection of tangent lines at a point on the given surface. Okay. Suppose the surface is given by the equation f of x comma y comma z is equals to 0, and the point is given as x1 y1 z1. Okay. Now we can write equation of tangent plane to this surface at the point x1 y1 z1. So the equation of tangent plane at x1 y1 z1 to the surface f of xyz is equals to 0 is given by dou f by dou x evaluated at x1 y1 z1 into x minus x1 plus dou f by dou y evaluated at x1 y1 z1 into y minus y1 plus dou f by dou z evaluated at x1 y1 z1 into z minus z1 equals to 0. Okay. So this is the equation of tangent plane to the surface f of x comma y comma z equals to 0 at the point x1 y1 z1. So you need to calculate the partial derivative of f with respect to x, with respect to y, and with respect to z, and substitute the points x1 y1 z1 in the partial derivatives. And you need to take x minus x1, y minus y1, z minus z1, adding all those and equating to 0, we will get equation of tangent plane. A surface is given by x square plus 2y square plus 3z square equals to 12. You need to find the tangent plane for this surface at the point 1, 2, minus 1. Okay, so let us find tangent plane. Now let us consider the surface equation as small f. So it is equals to x square plus 2y square plus 3z square minus 12, and identify partial derivatives with respect to x, y and z. So fx, it is dou f by dou x. This is 2x. Now fy, it is dou f by dou y. It is 4y. Then fz, it is dou f by dou z. It is 6z. Now tangent plane formula is equation of tangent plane. So it is dou f by dou x evaluated at the given point 1, 2, minus 1 into x minus 1, and dou f by dou y evaluated at 1, 2, minus 1 into y minus 2, and dou f by dou z evaluated at 1, 2, minus 1 into z plus 1 equals to 0. Now this is dou f by dou x. Substitute the point 1, 2, minus 1. It will be 2. So 2 into x minus 1. Now substitute y equals to 2. It will be 8. 8 into y minus 2. Now you write minus 1. It will be minus 6 into z plus 1 equals to 0. Now this will be 2x plus 8y minus 6z minus 2 minus 16 minus 2 minus 16 minus 6 equals to 0. So it is 2x plus 8y minus 6z minus 24 equals to 0. This is the equation of tangent plane at the point 1, 2, minus 1. Now let us take a surface xyz equals to 6. You need to find tangent plane for this surface at the point 1, 2, 3. Now let us assume the surface equation as small f. It is xyz minus 6. Now fx, it is dou f by dou x, and it is equals to yz. Then fy, it is dou f by dou y. This is equals to xz. Then fz, it is dou f by dou z. This is equals to xy. Now equation of tangent plane. The equation of tangent plane is, it is dou f by dou x evaluated at 1, 2, 3 into x minus 1 plus dou f by dou y evaluated at 1, 2, 3 into y minus 2, dou f by dou z evaluated at 1, 2, 3 into z minus 3 is equals to 0. Now dou f by dou x is yz. Substitute y equals to 2 and z equals to 3. It will be 6. 6 into x minus 1, and this is xz. It is 3. 3 into y minus 2. It is xy. This is 2 into z minus 3 equals to 0. This is 6x plus 3y plus 2z minus 6 minus 6 minus 12 minus 12 minus 6 minus 18 equals to 0. This is the equation of tangent plane to the given surface at the point 1, 2, 3. Let us assume u is a function of xy, okay, and x is a function of t, and y is also y function of t. Then finding du by dt, finding this ordinary derivative du by dt is called total derivative. Okay, so we will apply chain rule here, and this is equals to dou u by dou x into dx by dt plus dou u by dou y into dy by dt. Okay. If u is a function of x and y, where x is a function of t and y is also function of t, then finding the ordinary derivative du by dt is called total derivative. So we will apply chain rule here, and it is equals to dou u by dou x into dx by dt plus dou u by dou y into dy by dt. This can be extended to 3 variables also. Suppose u is a function of x, y and z, where each is a function of t. X is a function of t, y is a function of t, and z is also function of t. Then you can write du by dt. Okay, this is equals to take the derivative of u with respect to first variable and derivative of x with respect to t, and partial derivative of u with respect to second variable and derivative of y with respect to t, and derivative of u with respect to third variable and derivative of z with respect to t. Okay, so this ordinary derivative is called total derivative, and we have applied chain rule. So let us take a problem. U equals to x cube plus y cube, and x equals to a cos t, y equals to b sin t. We need du by dt, or we need total derivative. So here u is a function of x and y, and small a is constant, small b is constant. So x and y both are functions of t. Now you can write formula for du by dt. So it will be take the derivative of u with respect to first variable x into derivative of x with respect to t. Now take derivative of u with respect to second variable y, and take derivative of y with respect to t. Now dou u by dou x. Dou u by dou x is 3x square, and dx by dt is minus a sin t. Then dou u by dou y is 3y square. Then dy by dt is b cos t. Now you can write x equals to a cos t and y equals to b sin t. It is minus 3a into a square. It is a square cos square t into sin t plus 3b into y square. It is b square sin square t into cos t. Now it will be minus 3a cube cos square t sin t plus 3b cube sin square t cos t. So this is the value of du by dt, or this is the value of total derivative. The other question is you need to verify the result. Okay, for that, in order to verify, consider u, it is x cube plus y cube. So in order to verify, first convert u completely in terms of t. So x cube is a cube cos cube t, and y cube is b cube sin cube t. Now we are having u in terms of t, and we need du by dt, that is the first derivative. So a cube is constant. Now we need derivative of cos cube t. Its derivative is 3 into cos square t, and internal derivative of cos t sin t plus b cube into derivative of sin cube t. It is 3 into sin square t and internal derivative cos t. Okay, so here the derivative is, for derivative of cos t, the answer is minus sin t, not plus sin t. So it is 3a cube cos square t sin t plus 3b cube sin square t cos t. Okay. The previous answer is minus 3a cube cos square t sin t plus 3b cube sin square t cos t. Hence, by applying chain rule and by doing directly, we got the same answer. Hence, it is verified. Now let us see another formula in chain rule. Suppose u is a function of xyz. Suppose u is a function of xyz and assume that each is a function of st. Each is a function of st. Then you can write formulas for dou u by dou s and dou u by dou t. Write formulas for dou u by dou s and dou u by dou t. Now dou u by dou s equals to, take the derivative of u with respect to first variable x and derivative of x with respect to outside variable s. Then derivative of u with respect to second variable y and derivative of y with respect to outside variable. Then derivative of u with respect to third variable z and derivative of z with respect to outside variable s. Now you can write similarly dou u by dou t. It is derivative of u with respect to first variable and derivative of first variable with respect to outside variable. U with respect to y and y with respect to t, u with respect to z and z with respect to t. Okay, these are also called as chain rule or total derivatives. Let us see a problem in chain rule. W is x plus 2y plus z square and x is r by s. Y is equals to r square plus log of s and z equals to 2r. We need to find dou w by dou r, partial derivative, and dou w by dou s. It is also partial derivative. Here w is in terms of xyz. W is in terms of xyz and x is in terms of rs. Y is in terms of rs and z can be taken as it is in terms of r comma s. Now we need dou w by dou r and dou w by dou s. Now this is equals to dou w by dou x and derivative of x with respect to r. Next dou w by dou y, dou w by dou y and derivative of y with respect to r and dou w by dou z and z with respect to r. So you can remember we have taken derivative with respect to first variable and derivative of first variable with respect to outside variable. Next derivative of w with respect to second variable, that is dou w by dou y, and derivative of second variable with respect to outside variable, that is dou y by dou r. Then derivative of w with respect to third variable and derivative of this variable with respect to outside variable r. Now we have w equals to x plus 2y plus z square, then dou w by dou x is 1 and x is equals to r by s, then dou x by dou r is 1 by s plus w equals to x plus 2y plus z square, then dou w by dou y is 2 and dou y by dou r is 2r and w with respect to z is 2z and z with respect to r is 2. Now let us substitute the value of z here. It will be 1 by s plus 4r plus 4 into z value 2r So it is 1 by s plus 4r plus 8r. It is 12r. Now let us find the other partial derivative, dou w by dou s. So this is equals to derivative of w with respect to first variable x and derivative of x with respect to outside variable s. Then derivative of w with respect to second variable y and derivative of y with respect to outside variable s and derivative of w with respect to third variable z and derivative of z with respect to outside variable s. Now w with respect to x, it is 1. X with respect to s, it is minus r by s square. Then w with respect to y, it is 2. And y with respect to s, it is 1 by s. Then w with respect to z, it is 2z. And z with respect to s, it is 0. Now the final answer is minus r by s square plus 2 by s. Okay. These are the values of partial derivatives dou w by dou r and dou w by dou s by using chain rule. Now let us take another problem on chain rule. Z is a function of xy and x equals to e power u plus e power minus v, y equals to e power minus u minus e power v. Then we need to prove that dou z by dou u minus dou z by dou v is equals to x into dou z by dou x minus y into dou z by dou y. So given that z is a function of x and y, and we can see that x is a function of uv and y is also function of uv. Now let us write the values of dou z by dou u and dou z by dou v. So it is derivative of z with respect to first variable x and derivative of x with respect to outside variable u plus derivative of z with respect to second variable y and derivative of y with respect to outside variable u. Now z is not clearly defined, so it will be dou z by dou x. Now x is equals to e power u plus e power minus v. From that, dou x by dou u is e power u and dou z by dou v into y is equals to e power minus u minus e power v. Its derivative with respect to u is minus e power minus u. Now it is e power u into dou z by dou x minus e power minus u into dou z by dou y. Now let us start finding the other term, dou z by dou v. So this is equals to derivative of z with respect to first variable is x, and derivative of x with respect to outside variable v, and derivative of z with respect to second variable is y, and derivative of y with respect to outside variable v. Now z is not clearly defined, so it is dou z by dou x. Now x with respect to v, x with respect to v is minus e power minus v plus dou z by dou y into y with respect to v, it is minus e power v. Now this is minus e power minus v dou z by dou x minus e power v dou z by dou y. Now let us start with left hand side. This is dou z by dou u minus dou z by dou v. This is equals to dou z by dou u is e power u into dou z by dou x minus e power minus u into dou z by dou y minus e power minus v into dou z by dou x minus plus e power v into dou z by dou y. Now taking the terms common, it is e power u minus e power minus v into dou z by dou x plus minus e power minus u plus e power v into dou z by dou y. Now you can replace e power u minus e power minus v with x. It is x into dou z by dou x. Taking minus common, you can replace e power minus u minus e power v by y. It is y into dou z by dou y, hence proved.